we need to compute the integral from 3 to 5 of this function, say f of x dx. And you see that f of x square root of this one always greater than or equal to 0. So you can interpret this one as the area under this curve. So area under the curve y equal to square root 16 minus x minus 3 square. And here for x between 3 and 5. And this curve is actually circle, and we only look at x from 3 to 5 and y always greater than equal to 0 because it's the square root of this one. So now let's look at this. Square both sides, you have y square. You can move x minus 3 square to the left plus y square equal to 16, so 4 square. This is a circle. The center of the circle is 3, 0, and the radius r equal to 4. So in general, circle has the equation x minus a square, y minus b square, radius square. So center a comma b, radius r. Now come back to our question. We have the circle, we have the radius and center there. Let's sketch it. Center 3, 0. So 0 here, 1, 2, 3. 3, 0, the center of the circle. Radius is 4. 1, 2, 3, 4. So 7 here. Minus 1 here. X between 3 and 5. 3 and 5. So we have the region here. We need to compute the area. I only highlight the one above the x-axis because we work with y greater than equal to 0. We need to compute the area of this region. So radius 4, I put 4 here. Area under this curve, 3 to 5 square root 16 minus x minus 3 square dx. To compute the area of this region, we cut it into two regions, two sub-regions. Call the first one the right triangle here. I call it region 1, and I call the second region the region 2, like this one. Now let me compute the area of region 1, and then we plus with the area of region 2. Then we have the area of the region we need to compute, which is this integral. This integral equal to area of region 1 plus area of region 2. Area of region 1 is the area of the right triangle. So we have this right triangle here. One side has length 2 because this is 3 and 5. One side is of length 2. The hypotenuse of this right triangle is 4 because our circle is of radius 4. Now I can compute this length. This is the length that we don't know. We use Pythagorean theorem. The length of the other side is square root 4 square minus 2 square. 16 minus 4, 12. So we have 12 is actually 4 times 3. So 2 times square root of 3. 2 times square root of 3. And with that, the area is 1 over 2 times 2 times 2 root 3. 2 and 2 cancel out. You have 2 root 3 for the area of region 1. Now let us compute the area of the region 2. Region 2 is a circle sector. We need to compute this angle. The angle, I call it theta. We know that theta has to be this angle here. This is theta because the two lines are parallel. So theta here is equal to this one. Let's compute theta then. Theta equal to this angle. We can use trigonometric function here. Sine theta, sine theta 2 over 4, 1/2. So theta is arc sine 1/2. Theta between 0 and 90 degrees. Sine is 1/2. Sine 1/2. 1 over 2. So we know that our angle theta has to be pi over 6. Pi over 6. Now we compute the area of the region 2. You think about it this way. If you have full circle, which is 2 pi, then the area can be pi radius squared. Now we only have angle theta. This one will give us area pi r squared multiply theta divided by 2 pi. Multiply this divided by this. Pi and pi cancel out. You have theta radius squared over 2. Radius in our case is 4. Theta is pi over 6 and radius is 4. So this one is pi divided by 6. Radius squared 16 divided by 2, which is pi over 6 times 8, which is 4 pi over 3. This is the area of the region 2. Area of region 2 is 4 pi over 3. And therefore the total area is area of region 1 plus area of region 2. 2 root 3 plus 4 pi over 3. Conclusion. This interval is the sum of the two area of two regions. 2 square root of 3, 4 pi over 3. And this is our final answer.